right, we are going to take derivatives of inverse trig functions. So first of all, we need to remember what inverse trig functions are. Remember, inverse trig functions are undoing trig functions. If I tell you the cosine of theta equals 3, well, it doesn't actually, I'm sorry, 0.3, how about that? Then theta can equal cosine inverse of 0.3, or we could write it as arc cosine of 0.3. Arc cosine is the way you'll see it in calculus. The domains of these, remember, if you think about our unit circle, arc cosine is 0 to pi. Arc sine and arc tangent are negative pi over 2 to pi over 2. And then secant, cosecant, cotangent go right along with those, except that they have values that they're not defined in. The derivatives of the trig functions, here they all are. Arcsine and arctangent are the most likely to be tested on the AP test, so we will probably just focus on those, but this is all of those properties. U is always whatever's inside of your arcsine, arc cosine, whatever. U prime is the derivative of it. Absolute values on these two, arcsecant and arc cosecant. Oh, that's a typo. All right. On a calculator, arcsecant will equal the arc cosine of 1 over x, and arc cosecant will equal the arc sine of 1 over x. So that you know. All right, let's find some derivatives. The derivative of the arc sine of 2x. Well, according to our rules, arc sine's derivative is u prime over a square root of 1 minus u squared. So, 2y dx equals u prime, derivative of the inside here, which is 2, over the square root of 1 minus u, which is 2x squared. We could also write 2 over the square root of 1 minus 4x squared to clean it up a little. The derivative of arctangent of 3x. So dy dx equals the derivative of the inside, which is just a 3, over 1 plus the inside squared. So 1 plus 3x squared. So we have 3 over 1 plus 9x squared. The derivative of arcsine, we take dx equals derivative of the inside. The derivative of the square root of x is 1 over 2 square root of x over the square root of 1 minus square root of x squared. To simplify this a little, I'd put 1 over 2 square root of x, square root of 1 minus x. We could mush those together if we wanted, or leave it like that. And the derivative of arcsecant of e to the 2x power. Oof, fun one here. All right, derivative of arcsecant is u prime. So the derivative of e to the 2x, which is 2 e to the 2x, over the absolute value of u, which is the absolute value of e to the 2x, times the square root of e to the 2x squared minus 1. That looks nasty. Let's clean it up a little. E to the 2x power is always going to be positive. So this absolute value is completely pointless, and these can cancel, leaving me 2 over the square root. E to the 2x squared is e to the 4x minus 1. There we go. Let's find the derivative of this wonky madness. All right, derivative of arcsine dx. Derivative of arcsine is 1 over square root of 1 minus x squared, plus the derivative of this. So the derivative of x is 1 times the 1 minus x squared, plus x times the derivative of this madness, which is 1 over 2 square root of 1 minus x squared times negative 2x. Well, to get a common denominator, multiply this one by 2. Multiply this by 2 square root of 1 minus x squared. So my derivative is 2 plus 2 times 1 minus x squared plus negative 2x squared. over 2 square root of 1 minus x squared. Simplify this a little more. 2 plus 2 minus 2x squared minus 2x squared. And I get 4 minus 4x squared over 2 square root of 1 minus x squared. Divide everything by 2, and my derivative is 2 minus 2x squared over the square root of 1 minus x squared. Fun stuff. All right, let's take a look at our word problem here. Our word problem, we have a photographer taking a picture. The head of the painting is 4 feet. The camera lens is 1 foot below that. And how far should the camera be from the painting to maximize the angle subtended? That is this angle B. All right, so we're trying to figure out the max of B. We know that theta, the tangent of theta at least, is 5 over x. We know the tangent of alpha is 1 over x. So I can solve these and say theta is the arctangent of 5 over x. Alpha is the arctangent of 1 over x. And I know B is theta minus alpha. So that means B, oops, putting a green marker in there. B is the arctan of 5 over x minus the arctan of 1 over x. To maximize it, we want the derivative. dB dx. Derivative of arctangent is u prime, so it's negative 5 over x squared over 1 plus u squared, which is 5 over x squared, minus derivative of u prime, negative 1 over x squared over 1 plus 1 over x all squared. We're going to set that derivative equal to 0. Now there's a lot of algebra we can do to do this. Let's see here, negative 5 over x squared times 1 over 1 plus 25 over x squared minus plus 1 over x squared times 1 over 1 plus 1 over x squared. Let's see, we can make these denominators x squared over x squared. X squared times all this is going to cancel out those denominators. Negative 5 over x squared plus 25 plus 1 over x squared plus 1. I'm setting this equal to 0. I would get a common denominator, which would give me negative 5x squared plus 1 plus x squared plus 25 over the common denominator, which isn't going to matter in the end. So I have negative 4x squared plus 20 equals 0. Do the rest of our work over here. 4x squared equals 20, x squared equals 5, x equals plus or minus square root of 5. It's obviously not negative, so square root of 5 feet away to maximize our angle. All right, then you will practice.